Today we're going to do one of the first lessons. If your brothers or sisters, or if there are people in the math team here who probably know this, if they take a geometry class, they almost always gripe about one thing, right? They say this is the hard part. Anybody on math team here know when the 8th graders last year would talk about geometry, what they didn't like about it? Anybody know what that was? What was it?
Proofs.
Proofs, okay? Proving things very systematically, stepping one step at a time. When you prove things using facts and rules and properties, we're proving it with deductive reasoning, okay? So, and look, you can discover a pattern in something, but until you can prove it using deductive reasoning, mathematicians will not accept it as fact. Now, so proofs are important. We do this on math team all the time, right? We start off with something that we see patterns, and then we try to prove it algebraically. And once we prove it algebraically, we know it's always true. So there's I debated whether or not to tell you this story, but there's a very famous math story about proofs, okay? There was this man named Fermat. I don't know, let me look it up. Who's Fermat? Yes, so about the 1700s, I was right, yeah. In the 1700s, there was this guy named Fermat, okay? And Fermat was self-taught mathematician. He learned all this math. He was obviously a genius, right? And he did a ton of work on number theory, like number patterns and stuff like that. But the problem was he was poor, so no one listened to him. And back then he didn't go to a university, so nobody listened to him, right? So he basically just taught himself mathematics on his own, okay? But no one listened to him. But later on, after Fermat died, later on people stumbled across some of his writings, and they started realizing, holy cow, this guy was insanely smart. He was proving things that we've been trying to prove for years, but nobody knew he was smart, right? No one realized how smart he was while he was alive, right? So there was this one book that this notebook that he wrote down some problems. And in the margins of the book, he wrote down, he said, I figured out, here, let's talk about what Fermat's last theorem is. So Fermat came up with this theorem, right? He did prove it, but we'll get there in a minute. So there's this guy named Fermat, and his theorem says this: for a to the n plus b to the n equals c to the n, okay? We already know this is true for a squared, right? A squared plus b squared equals c squared, right? How many answers to this problem are there? How many answers can you come up with this problem? How many exist?
Infinite.
Right, there's an infinite amount of answers to this problem. So the next logical question is, well, what about for this? How many answers for that are there? How many answers for this are there? Can anybody think of numbers that work for these? Now there's some trivial ones, like make a 0, right? Make a 0 and then b cubed equals c cubed. So we call those trivial answers. But can you think of a non-trivial answer for a to the cube plus b to the cube equals c to the cube? Anyone know one? Mariah, Emily, Junie, can you guys think of one? No? Well, if you could, you would be a millionaire. You would be considered a math genius, because it has been proven that it doesn't exist. There are no other answers to these problems. If you go a to the 5th, if you go to a to the 100th, there's no other numbers that work that will give you a to the n plus b to the n. So that's what Fermat's last theorem said. In the margins of a book, he wrote down, I have proven how that a to the n plus b to the n equals c to the n is only true for n equaling 2 or n equal 1, right? It's only true for n equals 2. But he said, but the proof was so long that I can't write it in the margins of this book, so I'm going to write it down in another notebook. That's what he wrote. So in the margins of this book, there's this, in the margins, he wrote down, hey, I've solved this, but I don't have enough room here, so I'm going to write it down on another piece of paper. So he dies. People discover all his writings, and they realize he's a genius. And they're like, holy cow, he's proved this problem? So they go to his wife, and they say, hey, we've realized your husband's incredible mathematician. We would like to see his writings because he wrote down, they said he wrote down the proof to this, right? And they believed him because they realized how smart he was, right? And he was proving a bunch of other things. So they asked her, hey, can we see those writings? And guess what the wife said? Anyone know what the wife said?
No.
After he died, I burnt everything. I got rid of it all. I burnt it. It's all gone. 1700s, this happened. Yeah? So from that point forward, people thought that Fermat was right, but nobody could prove it. No one could do a proof of the mathematics behind what he had already discovered for himself. And in the 1990s, there's these things called the millennial problems. Anyone ever heard of the millennial math problems? There's 10 math problems that have never been proven mathematically that we think are true, but we've never proven. And each of those problems, if you can prove them, they're worth $1 million. And in the 1990s, a man finally proved Fermat's last theorem. He proved that a to the n plus b to the n equals c to the n is only true for n equals 2. So Fermat was right, but it took us over 200 years to discover that he was right. Actually, almost 300 years. 300 years, people had been trying to figure out his problem. If you get on YouTube, you can watch a video on the guy who discovers it. And it's kind of a sad story because in the story, he's kind of sad afterwards because he realizes that I just did something that I'm never going to beat in the rest of my life. I'm never going to do something better than this. And he was kind of sad at the end. Like, this is like the highlight of my entire life, right? So, but the thing is, everybody thought Fermat was right, but until they proved it, no one could use it, all right? So that's what we're going to do today is proofs. And we're going to start off with real simple proofs, algebraic proofs, all right? And before we can start those, we need to talk about some properties that we need. All right, so these all start off with if A equals B, okay? So they all start off with that. All right, for those, yeah? All right, so the addition property says this. If A equals B, then A plus C is equal to, what do you guys think? If A equals B, then A plus C is equal to what?
B plus C.
B plus C. That's called the addition property. Then A plus, so the subtraction is, I'm just going to go through these kind of quick, right? Then A minus C is equal to B minus C. Then A times C is equal to B times C, right? Then A divided by C is equal to B divided by C. Yeah, all obvious ones. All right, that's those obvious things, right? Why, if I divide both sides by the same thing, it's okay, right? If I multiply both sides by the same thing, it's okay. I'm allowed to do these. You've been using these all last year in algebra, so these are not things that you should already know. All right, reflexive property. Does anybody know the reflexive property? I would hope the math team does, but does anyone else know? All right, math team, what's the reflexive property?
A equals A.
Right. The reflexive property says this, A equals A. Something is equal to itself, which is kind of weird, but every once in a while we have to use that. All right, does anybody know the symmetric property? If A equals B, then
B equals A?
B equals A, that's right. You can flip things. That is useful for when we get things like this. If I say 1 equals X and I want to say that X equals 1, the reason I can do that is because of the reflexive property, okay? Transitive property. If A equals B and B equals C, then
A equals C?
all right. We already learned this rule the other day. What did we call this the other day? Somebody else? Jack is answering all the answers. What did we call it?
The law of syllogism.
Yep, law of syllogism, right?
Chain rule.
The chain rule, transitive property, okay? Chain rule, transitive property, okay? So same thing. All right. The next one, the next substitution property. If A equals B, then A can be substituted for B. And then distributive property. If A equals, how do they say it? Oh, distributive property says this. If A times B plus C is equal to AB plus AC. We already know that one. Okay, so we're going to use these to prove things mathematically, all right? So what you'll notice, these are called, what I'm doing here, this is called a two-line proof, okay? One is where you do the step, and then one is the reason. Properties, this is also, a lot of the time, this is the reason that you're allowed to do it, okay? So what you're doing and why you're allowed to do it. Every step has to have a reason. You can't just do something without it proving why you're allowed to do that, okay? And that's what happens with mathematicians. When they discover a new thing, they will go and write a proof for it, like what we're doing, and then they will send it out to hundreds of mathematicians. What is the job of those mathematicians, do you guys think? So they'll prove something, and then they'll send it out to a bunch of people. Why do they do that? What's the job of those mathematicians?
Solving math problems.
Nope.
To make sure that they didn't mess up.
They find mistakes. You give it out to hundreds of mathematicians, and it's their job to find one mistake. And if they find one mistake, your proof is not valid. So their job is to find your mistakes, yeah? So we're going to go step by step and have a reason. All right, step one. Anytime they give you something, that's your first step. You're always just going to write that. And the reason you can write that is that it's given, okay? So you always start off with what's given. That's how you start the problem. All right. Let's go somewhere. Jaden, you there?
Yes.
All right. So how did they go from this step to this step? What did they do?
They distributed the
Right. So distributive property is the reason I was able to do that. All right. All right. Next step. How does 6x plus 2x minus 2 equals 30 become 8x minus 2? This is one where you'll see it written differently. You can, if we were sitting in my class, I'd show you my book every once in a while. In the margins of my book, it says, I hate this book sucks, I cannot, if I ever met the people who wrote this book, I'd probably make fun of them, yeah? They'd be punchlines because they're just sloppy with their work. You can tell that a bunch of people made this book together because different people do it different ways and it's not consistent and there's things I don't like about it. Sometimes they will skip this step. They won't have it. They'll go straight from this step to this step, okay? But if they do have that step, right? There's two ways we can use this. Simplifying, okay? But sometimes they'll also use substitution. So substitution and simplifying mean the same thing. And how am I able to do that? Because we know that 6x plus 2x is the same thing as 8x. So you can substitute 8x in for 6x plus 2x. You don't have to write this. I'm just showing you why that's true, okay? So anytime we simplify it, you can just write simplifier or substitution, okay?
Would symmetric work for it if 6x plus 2x is A and 8x is B?
Say it again.
Would symmetric work if 6x plus 2x is A and 8x is B?
So yes, but you're doing extra steps to do that. Does that make sense?
Okay.
Okay. All right, next step. What are they doing? They're adding 2 to both sides, addition property. Then what are they doing? They're simplifying, right? Simplifying or substitution, okay? Then they're dividing both sides by 8, so division property. Right? And then what are they doing? Simplifying or substitution. Can't spell. Okay. So all we're doing is something that we've already done before, but we're just putting the reasons with it, and we're being very systematic with what we're doing. But last year when you were learning algebra, this is the reason that you could do everything you did. Does this make sense, guys? Yeah?
Yes, sir.
Yes.
Yeah? All right.
Yes.
So how do we do these? Well, we're going to do steps and reason, right? These are called 2-line proofs because you have 2 pieces going on at the same time. All right. First step, you always start with the given. So you just write what they gave you. 4x plus 6 over 2 equals 9, right? What's the reason that I'm allowed to write that? Someone?
Given.
Given.
Given. Okay. Okay, so let's see. Let's do Henry. I didn't teach you algebra, so what would your first step be, Henry? I'm curious. What would you do first?
I'd probably multiply both sides by 2.
Good job. That's exactly what I would do too. So now watch this. We have to show that we're going to double both sides. Okay, we have to show that. We can't, you know, in an algebra class, we would have just doubled both sides from the beginning, but we have to show the step here, okay? All right, so Henry, why am I allowed to do that?
Because of the multiplication property of equality.
Yeah, multiplication property. We can just call it multiplication property, okay? All right, and then we're gonna write 4x plus 6 equals 18. And we're just gonna start calling it substitution, okay? Substitution is the same as simplify, okay? So you might as well just get used to using substitution there. Sometimes they'll use the word simplify, so just be ready for that, okay? All right, next step, let's see, Jack, next step.
Subtract 6 from both
So
sides.
we have to write it like this, 4x plus 6 minus 6 equals 18 minus 6. Subtraction, right? Okay. Then we simplify. 4x equals 12. That's substitution. And then let's see, Jackson, now what do I do?
Divide each side by 4.
So we have to do 4x divided by 4 is equal to 12 divided by 4. Division property. Then we get x equals 3, substitution. Questions there? Okay. Now we're going to get a lot of the things that we used, right? The reflexive, the symmetric, and the transitive is also true with segments, right? AB is equal, the segment AB is equal to AB. The measure of angle 1 is equal to the measure of angle 1, okay? I'm going to add one here. I'm going to add one called the definition of congruent, okay? And it says this. If, I got to be careful how I do this. Give me 1 second. I need to write this carefully and not mess this up. Yeah. If the measure of angle A is, no. If angle A is congruent to angle B, then the measure of angle A is equal to the measure of angle B. Okay, what am I saying here? I'm saying if the angles are congruent, then their measurements are the same, which is kind of common sense. Sometimes the book will skip this step, and it really is annoying when it happens because you're looking for an extra step or it's missing a step. Definition of congruent says if they're congruent, then they're equal. That's all we're saying. Thumbs up, does that make sense? If things are congruent, then they're equal. That's definition of congruency. So if they ever go from congruency to equality, they're using definition of congruent, okay? All right, so what do we have here? All right, step and reason, right? Okay, if I would make a suggestion to you, I would always look at the problem and just work it out for myself first. So let's look at what it says. What do we know? This angle is congruent to this angle. Okay, so this is equal to this. That's what it says. What else does it say? It also says that this angle is equal to this angle. So this angle is equal to this angle. Yeah? Well, how can I, is there a way to link then this, and this? Is there a way to link those?
6x plus 7 equals 8x minus 5.
Okay, what's the reasoning?
The law of syllogism.
Okay, which we call now the transitive property, right?
Yeah, transitive.
Transitive property. Okay, so that's where we're going with this. All right, when the given is really long like this, and you have to write it all out, it's annoying, and I hated that as a kid, okay? I hated writing it all out. So if it's really long, we will do a special thing that only works in my class. Anytime it's really long, you can just write blah, blah. Not blab, blah, blah. What does blah, blah mean? Blah, blah means whatever the heck they set up here. Save us some work. What's the reason for blah, blah?
If it's really long.
Yeah,
Save work.
It's
Yeah.
given.
really long.
Given, right? It's the given stuff, yes? Okay, now watch this. Look what they're saying. This is congruent to this, right? This is congruent to that, so these must be congruent by transitive property, right? So that's my first step. Angle FGJ is congruent to angle KGH because of the transitive property. And since I know they're congruent, then I know that the measure of angle FGJ is equal to the measure of angle KGH. How do I know that?
Definition of
Definition
congruent.
of congruence.
Yeah, definition of congruent, okay? They'll sometimes say definition of congruent angles, but we can just write definition congruent, okay? All right, from here, I'm curious. Ginny, what do I do now? What do you think? I'll give you a hint. 6x plus 7 is equal to 8x minus 5. Why is that true?
The symmetric.
What's symmetric property say? Symmetric property says if AB equals CD, then CD equals AB. I didn't flip this around. I didn't flip these. So no, it's not symmetric. Look at the given. Look at this key right here. Look at this. What's written here and what's written here. What do you notice? That was given, right? That's a given part of the problem.
Yeah.
So help her out, somebody. It's hard for some people to see this at the beginning.
Given.
Isn't it a substitution?
Given.
No, look, this is not given. This is not given anywhere. Look up here. There's nowhere does it say that. So no, it's not given.
I think it's
Isn't
changing.
it substitution?
Substitution. Whoever said substitution is right.
Simple.
Substitution. Look, we just set up that the measure of this angle is equal to the measure of the angle, and we know that the measure of the angle is 6x plus 7. So since they're equal, we can substitute it. Yay or nay?
Yay.
Yeah.
All right. Okay. Now it's just an algebra problem, so let's just do it. Ready? Then I'm going to do 6x plus 7 minus 6x is equal to 8x minus 5 minus 6x. Yeah? Subtraction. Then I get what? 7 equals 2x minus 5. That's called substitution. Or simplifying, right? And the rest I'm just going to do step by step. Then I'm going to do 7 plus 5 is equal to 2x minus 5 plus 5. Addition property, right? Then I get 12 equals 2x. Substitution. Sometimes, guys, they're going to go straight from this step to this step. They'll skip this step. And depending on whoever was writing that section of the book and how much they hated the world that day, they might skip that step. So, all right, substitution. Then we're going to do 12 divided by 2 is equal to 2x divided by 2, division. So then I get what? 6 equals x. Substitution, right? Am I done? Did I prove what I needed to prove?
Yes.
Yes.
No.
Good job, Junie. The answer is no. What did I just prove? I just proved that 6 is equal to x. What's the question? Prove what?
Verify the conjecture.
Prove, what does it say at the beginning? Let's go all the way back to the beginning. What does it tell me to prove? It didn't say prove that x is equal to 6. It said prove x is equal. It said prove x is equal to 6, not 6 is equal to x. Don't get to the finish line and fall on your face. We're not done. What do we have to do now? We need to flip that around, right? So I need room over here. So I'm going to do it here. X is equal to 6. Why is that true? Why am I allowed to take 6 equals x and turn it into x equals 6?
Symmetric.
Symmetric property. That's when we use a symmetric to flip things around. If you're talking, I can barely hear you. Whoever's talking there. If you have a question, Mariah. Mariah? Okay. So let's do it again. Last problem. All right. Step, reason. 2-column proofs, right? Since this is pretty small, I'm just going to write it, right? So angle A is congruent to angle B, and the measurement of angle A is equal to 37. That is given, right? All right, what do you guys think? What's the next step? Anyone want to take a shot at it?
A equals B. Angle A equals angle B.
Okay, you're close. The measure of angle A is equal to the measure of angle B. Yeah. Why am I allowed to do that, Jack? Definition
of congruent.
They're saying they're congruent, so thus they're equal. Yeah? So then I can write, anybody know what the next step is?
Putting 37 equals 37, because that's what the measures of the angles equal.
Okay, then what would that do for me? You could. There is a way to do what you're saying, and it will work. It's not the way I would do it, so I'm going to stay away from that. But there is a way to do what you're saying right now, and it will work, okay? But it's not going to be the way that I'm going to do it.
Okay.
Come on, guys. I wrote these two together. They're right next to each other, so it's probably something to deal with these two.
Measure of angle D equals 37.
You can't flip it. You're close. Come on, look here. Look, watch this. Let me see. Look, angle A, angle A.
Is it
A
true?
is 37.
30.
Measure of
37 equals measure of angle B.
Okay, so 37 is equal to the measure of angle B. Why? Substitution. And am I done?
No.
No. The measure of angle B is equal to 37 because that's what I'm supposed to be proving, and that is the symmetric property. Okay, I'm going to be honest with you. This is going to take a while to get good at. Okay?
Mr.
Go ahead.
Couldn't you do, or would it work if you did measure of angle A equals 37 too?
Yes, but the problem is I'm supposed to be proving that angle B is 37. So then I would have to go, you could say the measure of angle A is equal to 37 right here. Yeah, I guess you could, Josh. Yeah. Actually, I think I like what Josh just said better. Watch. From this, we know this is true, right? That was given. I think last period, this is the way I did it. Yeah, let me do this. Let me write it down here. Okay, so we got the blah, blah given, right? Then we know that the measure angle A is congruent to, oh no. Then we've got the measure of angle A is equal to the measure of angle B, right?
You don't want us writing this down, right?
No, just watch. I'm just saying another way to do this. I'm going to try to do it the way Josh was reminding me. Wait, Josh, what were you saying? Say it again, please.
Measure of angle A equals 37. That would work, I was asking.
So, okay, so he's saying the measure of angle A is equal to 37 with substitution, okay? Right? And then I could say the measure of angle B is equal to 37 by substitution. And then I could be done. Now, why am I allowed to do that? Because I've already established here that A is equal to B. And since I have an A here, I can substitute it for a B. And I think that saves us a step, if I'm not mistaken. Yeah, it does. It keeps it one step less. Which way is the correct way?
Both.
Both. Okay. And I think last period, that's the way I did it. I think I did it that way last period, and I wasn't thinking, so. All right. So your homework tonight, actually, let me stop recording. 1 second.